Okay, we're asked to determine the measure of the angle. In the figure we're given, so here's our figure. Angle ABC measures 125 degrees. With the floor, this is the floor, and then L1 and L2 are parallel to each other. Okay, so ABC, we know that measures 125 degrees. So that can be helpful to us. So ABC, which is this angle, that's 125 degrees. In 69, we're wanting to know what is GBC. So what is GBC? 70 is going to be EDF. And then, let's see, we have DFE and then DEC. So you can see we have some answers here. Well, let's see how did we come up with these? So let's start with GBC angle. And so here is my GBC right there. And a few things we need to look at is look at the angle that goes from A, that joins those two, I guess we should say. If we, here's the angle ABC, and then it's finished, the rest of it's GBC. So I just need to know what that little part is right there. If I put these two together, that forms a straight line, a straight angle, if you will, which equals 180 degrees, because all straight angles are 180 degrees. So we're going to need some information from section 9.1 also to help us work through these questions. So that's 180 degrees. Now I have enough information to figure out what GBC is, because I'm going to take that 180, which are both of those together, and subtract that 125, because they told us that angle was 125 degrees. And so that will give me 55. So that's how we get 55 here for GBC. Okay. All right, so let me erase this so we can look at 70. Of course, keep in mind we know what GBC is now, because that might come that's going to come in handy for us. So we know this is 55 degrees. Okay, so this is 55 degrees. Now we need to look at what's some angles that are going to have that same width. Okay, so we probably will have some here if we think about what we have. So if I know this one is 55, okay, so let's look at we have a few triangles here, which also is going to be helpful for us. So these are really this angle. If you think about here's two parallel lines, if we extended them out, and this is a traverse, okay, and then we have this line, or segment, which forms 90-degree angles, which gives us some right triangles. So if this is 55, so that means if I extended this line out, okay, so these are going to be parallel. Okay, so if I could extend that line out, let me just go ahead and draw it out here. So if I could extend, I'm just going to extend these out a little bit. Because since these are 90-degree angles, they're going to be parallel to each other. Okay, so that helps us out because those are parallel lines. So that tells me this angle, this angle. These are all the same measure. Okay. And again, since these are parallel lines, so let's look at this angle right here, here to here. So that's going to be the same, that's going to be 55 degrees. Okay, 55 degrees. And you might be like, how do you know that? Well, go back to page 486 and 9.1. Those are corresponding angles, which are equal to each other. Because you have two parallel lines. This is parallel, and this is a transverse going through those parallel lines. So those corresponding angles are equal to each other. Now that I know those are equal to each other, well, let's look at this line and this angle. Well, that is also parallel lines with the transverse. Those are corresponding angles, so that's going to be 55 degrees. Okay. And this really comes with practice of just knowing the equations, or not necessarily equations, the definitions on page 486 about parallel lines cut by a transversal. If you know one angle, really in that case, you can figure out the rest of the angles that you're given just because they are parallel lines cut by transversals. So EDF is 55 degrees, just like GBC. Okay, let me clear all that. All right, so let's go back and let's look at, so we got 69 and 70. Let's look at 71. So 71 is DFE. So we're looking at DFE. So we're looking at this angle here. Okay. Well, again, we already know what EDF is, right? We just figured out EDF. That was 55. We know this angle right here is 90 degrees. That's what the little box means, 90 degrees. So now I can figure out DFE just by knowing that all the angles in a triangle equals 180 degrees. Right? Remember, in a triangle, all the angles equal 180. So I have 90 plus 55, which is 145. And if I subtract it, that's going to give me this angle. So let me do my subtraction, and it looks like I get 35 degrees, and that's what DFE is, 35 degrees. Now that's not the only way I can find that. We could use the fact, let's see, that was EDF, which was this angle. Actually, EDF. Sorry, had to make sure I was in the right spot there. We know EDF is 55. And we found DFE, so we found that one. 90 degrees. Again, we could probably use transverses, so we could say that there's our transverse there. We know this is 90 degrees, and of course that we could use corresponding angles, right? Because we said this angle, these are all going to be the same, which is 55 degrees. So we have 90 plus 55, which is 145. And then again, we have that angle, remember that equals 180. So 180 minus 145 is going to give us the angle we were looking for, which is going to be 35 degrees. So again, more than one way to figure out an angle here. So let me clear all that. All right, last one is 72. So 69, 70, 71, and 72. DEC. And it looks like we got an answer of 125. Well, let's see how that happened. So DEC. DEC GBC, so that's the angle we're looking for right here. So we know, all right, so let's go back here. We know DEF is 90 degrees, right? We know that one in there is 90 degrees because they give us the little box, which means it's a right angle, which is 90 degrees. That may be helpful, may not be helpful. We can, and think about it, are there any that we can go back to extending this out, which I think is very helpful, because remember that's parallel to this bottom line. We already know what GBC is. Remember that's 55 degrees. That means this one was 55 degrees. So we have 90 degrees, which goes from here to here. We have 55, and then we just need to know, let me find me a different color here. We want this angle right here. All right, so we need that one. Well, we know we have 90, which was there. We know this 55. We can add those two together. We get 145. And again, remember, if we add all three of those angles together, we should get 180. So if I subtract 145, it looks like I get 30. Oh, I'm not wanting to know what that angle is. I'm wanting to know what the whole angle is. Let me clear that. I was looking for the wrong, because we're looking for this one. I apologize. I was just looking for that little one in there, but actually we want both of those. Okay, so we did determine that one's 35 degrees, so we take 90 plus 35, which we need to know that, and that's going to give me 125. Sorry, I had too much going on there. We still needed to extend that out. That gave us the 55 because of corresponding angles. So we knew this one was 90, that one was 55. That gave us this one, which is 35, but that was not the final answer I wanted. I want to take that 35 plus 90 and get 125. So hopefully that wasn't too confusing. I find this interesting, but it can be very confusing. And again, it's very, very important that you know the properties of parallel lines cut by a transversal, which is on page 486 of your textbook. And you also need to know the measurements of particular angles on page 484, because you need to know a straight angle equals 180 degrees. You also need to know a right angle is 90 degrees.